Alright, so next we're going to talk about the points of inflection. So a point of inflection is just where the graph of a function has a tangent line, even if it's vertical, and where the concavity changes is called a point of inflection. So unfortunately, we can't just say, okay, the second derivative is equal to 0, so therefore blah 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 blah. We have to show that it actually changes sign, to be honest. So using each picture, it says estimate the point of inflection, if any, and sketch the tangent line at that point. So I've got concave up to about here, and then it flips to being about concave down here, and then flips back to being concave up here as well. So there's actually two tangent lines. One will be looking like that-ish. I'm terrible at drawing these. So if you're like, no, that's not what it looks like, cool beans, more power to you if you know how to actually graph these. But you're basically trying to draw the slope of the line that passes through that point. Alright. On this one, this next one, it went from being, what is that, concave up to being concave down. Oops. About here. So I've only got that one tangent line. And it should be dang near vertical. It might have a slight slope. Alright. And then the second part, or the third part, sorry. That whole thing is concave up. It looks like a parabola, which means that it is concavity, and it is going up the entire time. Since the points of inflection occur when the graph changes concavity, and the graph changes concavity when the second derivative changes from positive to negative, or vice versa. Alright, then we want to find these things called points of inflection, and we only need to focus on when the second derivative equals 0, or when it doesn't exist. So, important little note here, just because the second derivative equals 0, or it doesn't exist, we're not necessarily guaranteed that a point of inflection happens. So the second derivative absolutely has to change signs, meaning that the concavity changed in order for points of inflection to exist. If it's just equal to 0, that doesn't tell you jack, okay? So make sure you're checking to see if it changes signs. Alright, so let's go ahead, let's look at this example. Alright, so we need to find the points of inflection where g of x equals 3x to the 5th plus 10x to the 4th plus 15x plus 7. Alright, points of inflection. Tell me I'm looking for where does g double prime change signs. And that almost rhymes, so it's kind of cool, I guess. Alright, so first step's probably finding your derivative. So I've got g primed of x should equal 15x to the 4th plus 40x to the 3rd plus 15. And then g double primed of x is going to equal 60 x cubed plus 120 x squared, I believe. Alright, and then set that equal to 0 to kind of figure out where your, what we'd call critical values are. So then I got 0 equals 60 x cubed plus 120 x squared. Factor that, so I get 0 equals 60 x squared sitting on the outside, and then I should just get what, x plus 2 on the inside. Alright, so x could equal 0 and x could equal negative 2. So now we make our happy little sign chart. We've got negative 2, we've got a 0, and then we plug in something before negative 2, so negative 3, for example, would work. That would give me a positive times a negative, so that should be negative. If I plug in negative 1, for example, I should get a positive times a positive, and then if I plug in 3, for example, after 0, I should get a positive and a positive. So overall, this piece is positive, and this piece is also positive. So then we got to determine, do I have a point of inflection? If so, where? So again, need to make sure that that G prime changes signs. All right, so G double primed only changes signs once, so 0 in this particular case. Really, honestly, just not that important in this particular case, because it just goes from positive to staying positive. So all I can say is that at x equals -2, G double prime changes signs from negative to positive. Therefore, there is a point of inflection at x equals -2. And in order to figure out where that happens at, we actually need to plug that back in. Where we're going to plug that in at is actually the original function. And I hop, skipped, and jumped and grabbed a calculator, and I found out that the point of inflection is at -2, 41.